Hello, everybody. My name is Daniel Heibel, and this is the Rivian Adventure Station, a senior project done through Grand Valley State University. Rivian is an electric vehicle manufacturer that aims to keep the world adventurous forever. They are based out of Irvine, California, with manufacturing operations in Normal, Illinois. They will be producing 3 vehicles off the start: the R1T, which is a truck, the R1S, which is an SUV, and the RPV, which is Amazon's new delivery vehicle, all built off the same platform, meaning same battery system and drivetrain. This system will aim to serve the truck, which is releasing in September of this year. To do some introductions of our team, Adam Duke is our team captain. His major is in mechanical engineering, and his co-op was at Rivian. I, Daniel Heibel, is our sponsor point of contact. My major is in mechanical engineering, and my co-op was also at Rivian. Drake Ellens is our advisor point of contact. His major is in product design and manufacturing engineering. His co-op was at Cascade Engineering. Alexander Kanicki is our secretary. His major is in electric engineering, and his co-op is at Dematic. Nick Zawalski is our design engineer. His major is in mechanical engineering, and his co-op was at Adient. So the scope of our project: we will produce an adventure gear repair and preparation station. We will serve 2 main adventure activities. First, skiing and snowboarding. Our system will be able to mount skis and snowboards, be able to perform necessary preparation and repair for the skis and snowboards, and be able to heat and dry boots and gloves. Next, on the biking side of things, we will be able to perform bicycle maintenance and repair, and also be able to mount a bicycle to facilitate this repair. These functions will be integrated into Rivian's gear tunnel and slide system, which can be seen on the right-hand side of the screen, allowing the system to slide out of the side of the vehicle to perform this maintenance in the parking lot or trailhead of the desired activity. Some of our key specifications are: our system cannot exceed a weight limit of 200 pounds. It must fit within the dimensions of the gear tunnel to allow for storage while the vehicle is in operation. All of our electronics must run off 110 or 12 volts, as that is what is provided for us through the slide system, and our power consumption must not exceed 1.5 kilowatts. So to go through some of our ski and snowboard specifications, our system should be able to heat and dry boots and gloves at a targeted temperature of 105 degrees Fahrenheit, plus or minus 15 degrees Fahrenheit. Also with a minimum water removal rate from the system at a spec'd out 5 ounces per day. We should also be able to mount skis and snowboards at an SAE specified ergonomic height of 40 to 48 inches from the bottom of the tire. We should also be able to perform preparation and repair, including waxing, edge tuning, or base repair, meaning we will include all of the necessary tools to perform these operations. To go through some of our bicycle mounting and maintenance specifications, we should be able to mount a bicycle at an ergonomic height between 45 and 75 inches from the bottom of the vehicle at the vehicle park height. We must also hold the weight of a mountain bike, specifically an electric mountain bike, which we have spec'd out to weigh roughly 70 pounds. We should also be able to perform bicycle maintenance and repair, meaning any maintenance for brake, chain, seat, pedal, wheel, and tire repairs and maintenance, meaning we will include all the necessary tools and amount to perform these operations. In the beginning stages of this project, we went through some concept generation. To go through our initial stages of concept generation, we will begin on the left-hand side of the screen. This concept featured swing out arms to mount a ski and snowboard, as well as a side loading storage unit for boots and gloves, as well as ample drawers to store all the necessary tools. This system also featured a bike mount that would be mounted to the ground and not the system, making an entirely removable and stored bike mount. Now moving to the center concept on your screen, this system featured a longitudinally supported ski and snowboard mount, as well as a removable tray to help collect any wax sheathings that would be emitted by the waxing process. This also featured an end-mounted boot and glove storage solution, as well as larger drawers for the necessary tools. The final concept is seen on the right-hand side of the screen, also features a removable bike mount, swing-out tabletop-style arms that would be facilitated by clamps to mount the ski and snowboard, as well as an end-mounted boot and glove dryer storage solution, also featuring drawers for the necessary tools. Now to go over our selected concept. This concept mounts to the Rivian gear tunnel slide system using T-slots. It also features a modular design featuring two separate modules that can each be removed independently and arranged in the necessary order for the customer. The dryer module is responsible for storing and drying boots and gloves, in this image seen on the left-hand side of the screen. The maintenance module is responsible for storing tools, mounting of skis and snowboards, and mounting of a specified bicycle. First, to go over our detailed design of the dryer module, this module features a top opening lid for boot and glove dryer access. Also features a dehumidifier for water removal of any generated humidity. It also features a water catch tank for any runoff and also dehumidifier water storage. Reservoirs can be drained from a hold to drain valve on the exterior. Electrical controls are also stored in an internal compartment. To break down the detailed design of the dryer module even further, all water runoff drains through a one-way valve into our storage water tank. The dehumidifier reservoir is connected to the water runoff reservoir through a hose. When both reservoirs are full, the dehumidifier shuts off automatically. The electrical box features an outdoor rated extension cord, which is connected to the available 110 volt outlet on the gear tunnel slide. A waterproof switch controls the thermostat and the boot dryers and the dehumidifier. The thermostat monitors the temperature and will shut off the boot dryers and the dehumidifier if the maximum temperature is reached. To break down the detailed design of our maintenance module, all tools will be contained within 4 drawers on the module. 2 drawers will be dedicated to any tools required for bike maintenance, and another 2 drawers will be dedicated to any ski and snowboard specific tools. These drawers will all be pushed to open. An outdoor rated electrical outlet will be located on the surface of the module. This connects to the second 110 volt outlet on the slide system. This outlet will facilitate any power requirements needed during maintenance, specifically during the waxing operation. This system also features a extendable ski and snowboard mount. All mounts located on this are removable on a sliding system to accommodate all lengths of skis and snowboards. A stop prevents the slide from extending too far outside the module. An image of the extended slide can be seen on the upper left-hand side of the screen. The bike mount is secured within its own compartment. A lid for this system is kept in place via magnets for easy removal upon use. A 180-degree turn is used to extend the bike module past the end of the module to allow for a freestanding bike. a telescoping cylindric system is used to protrude the mount above the surface of the module. Some FEA analysis was done on all these components to analyze their mechanical stability. For the bike mount, a 70-pound downward force was applied. Our bike mount is constructed out of 6061 aluminum, which has a yield strength of 35,000 psi. Applying this force, a stress of 13,000 psi was seen. The system will not yield with a factor of safety of roughly 2.5. The model was also correlated with hand calculations in order to validate the model. FEA analysis was also run on the drawers located inside the maintenance module. A 20-pound distributed load was applied on these drawers, which accounts for all tools of the system loaded into one drawer. The actual load for the system is around 2 pounds. The allowable deformation for the system is 0.25 inches, as that is the spacing between the drawers. A deformation with this load of 2.11 inches was seen. These drawers are constructed out of 6061 aluminum, also with a yield strength of 35,000 psi. This system saw a stress of around 8,000 psi, giving us a factor of safety of close to 30. This model was also correlated with hand calculations. Finally, FEA was run on our ski and snowboard mount system. A 65-pound downward force was applied. This accounts for a 15-pound ski and snowboard and a 50-pound downward force applied from the user during any operation. This arm is constructed out of 6061 aluminum, again with a yield strength of 35,000 psi. Under this loading condition, a stress of around 10,000 psi is seen, giving us a factor of safety of about 3.2. This model was also correlated with hand calculations. Finally, to go over our budget, our total cost of this project is just under $5,000. With the allotted donation required through Grand Valley State University of $1,800, this brings our total budget to under $7,000. So that is all from us here at the Rivian Senior Project team. Thank you for your time, and I hope you all have an adventurous day.